Okay guys, today we'll be doing frames. I'm running a lesson under frames N3 engineering science. Here we've got a truss frame structure which we've got about 1, 2, 3, 4, 5 joints, which is supported from side A and E, and it has got a 200 force which is applied at D. And then our structure, it has got about 3 equilateral triangles, which is 1 meters from each side. So the first part which we are doing, we're going to be starting on finding the reactions, which is reaction at A and reaction at E. So in order for us for doing that, we're going to treat our structure as a free body diagram. Therefore, if ever we treat it as a free body diagram, we're going to have a structure which is like that, which has got that 200 newtons which is applied at D, and then we've got our reaction on this side, which is reaction A and reaction at E. So if ever we've got our reaction at A and our reaction at E, so the distance here is going to be 2 meters because it's 1 meter long, 1 meter long. Therefore it's going to be 2 meters. And then we try to find our reactions, because if ever we check our structure is pin jointed, therefore we've only got the reactions which are going up, which is reaction A and reaction E. So now if ever we treat that as a free body diagram, we're going to say forces on the y direction, which is forces on the y direction equals to 0. Therefore we're going to say our forces going up, it's going to be positive, and then our forces going down is going to be negative. Therefore, if ever you check there, you're going to say the sum of forces going up and then the sum of forces going down equals to 0. Therefore, it's going to be our reaction at A, which is that reaction, plus reaction at E equals to, and then we say net minus 200 newtons, which gives us 0 because it's the sum of forces. Therefore, we can simply say our reaction at A equals to 200 minus reaction at E. Therefore, we can get our equation 1. And then in order for us to find the reaction, because we got our reaction at A as the subject of the formula, we are treating it as a free body diagram. So now, if ever we want to find the reaction at E, we have to take moments around A. So if ever we take the sum of moments at A, it simply means that we're going to say clockwise moments equals to anti-clockwise moments, or sum of moments equals to 0. And then you decide if ever your conversion is going to be how you're going to take it, as if like your moments going to the clockwise direction equals to 0, equals to negative, and then the other ones equals to positive. So I prefer to say clockwise moments are always positive and then anti-clockwise moments are always negative. So if ever we take moments at A, so you're going to take moments at A, therefore what we're going to do, we're going to check that moments at A, we're going to have our 200 newtons, which is going to tend clockwise. Therefore if ever we cut that, meaning the distance between A and that force which is applied there at point D, the distance is going to be not 0.5 plus 1, which is going to give us 1.5 meters. Therefore we're going to say moments which are going clockwise, which we said clockwise moments because this is going to cause a clockwise moment, times the perpendicular distance, which is 1.5. Therefore we're going to say our 200 newtons, our 200 times 1.5. And then we've got our anti-clockwise moment, which is caused by reaction E. And then if ever we say anti-clockwise moment is going to be negative, we're going to say minus reaction E times by 2 equals to 0, because we're doing the sum of moments. And then we can be able now to calculate. Therefore we're going to say 200 times 1.5, which is 200 times 1.5. It's going to give us an answer of, let me check for my calculator, which is 200 times 1.5, which gives us what? Which gives us 300. Therefore, you're going to have 300 minus 2RE equals to 0. Therefore, you simplify for RE. Therefore, your RE is going to be equals to 300 divided by 2. Therefore, your reaction at E is going to be equals to what? It's going to be equals to 150 newtons. So, we've got our reaction at E, which is this reaction. It's going to be RE. Therefore, if ever you check again for your reaction at A, you have to go and check for your reaction at A, meaning you're going to go and recall your equation, which we named it as equation 1. Therefore, you're just going to simply substitute, which is your reaction at A equals to 200 minus your reaction E, and then you substitute your reaction E by 150. Therefore, it means that it's going to be 200 minus 150 newtons. Therefore, you get your 50 newtons. Therefore, now you've got your reactions, meaning your reaction at A is going to be 50 newtons, and then your reaction at E is going to be 150 newtons. Therefore, now you're done on 5. Okay, now you can see the diagram which we drew the first truss now. We've broke it down to each and every joint which is on the truss. As we calculated on the first part the reactions, and then we got our reactions as 50 and 150 newtons. So now what we're doing, we are breaking it down to each and every joint. If ever you check, we've got a joint there at A, we've got a joint at B, we've got a joint at C, we've got a joint at D, and a joint at E. So what we're doing now, we're breaking it into members, because if ever you check, we've got a member which is AB. That member of AB has to have its own magnitude and its sense of whereby is it under tension or is it under compression. So by breaking it into joints, we're trying to find the magnitude of the member, and also if ever is it on tension or is it on compression. So now what we're doing now, as we break it, you can see all the arrows. It shows that all the members, what I assumed is that all the members to be on tension. And then as you are calculating the members, if ever you find your assumption of direction is wrong, it's going to give you what? It's going to give you the answer as negative. So this is what we're going to do now. We're going to start with this member, with this part, which is this joint, which is this joint at A. And then if ever we take that joint, you're going to see that you're going to have a joint like that, and then you're going to have that 50 newtons, which is acting on that side. And then you've got this direction, because we're assuming that member AB is under what? Is under the tension. Therefore, you've got that member which is AB on this side, and then you've got this member which is on this side. We also assumed it's going to be on what? It's going to be on tension. Therefore, you've got this member which is AC. After you've got that, you just got that free body diagram of yours. What are you going to do? You're going to try to break down those members by making what? By calculating the sum of forces. We know that on the free body diagram, sum of forces going up equals to the sum of forces going down. So now, you've got your AC, which is going on the what? On the direction which is going to the direction on the right, which is going this way only. But now, we're going to start with the sum of forces going up, with the sum of forces going down. Therefore, what we're going to do, we're going to break the member which is AB into its components. If ever you check AB is going this way, which is the member of AB, therefore you can break your member which is AB into its components. Therefore you're going to have your component which is going to the right, and also you've got the component which is going up. Therefore you're going to name this component as what? As AB. It's going to be AB sine 60, because it's the y component of AB. And then on this side we're going to have your component which is AB cos 60 degrees. Because if ever you remember, you check on the first structure which we had, all the angles that we had what? We had the angle of 60 degrees. So now this is what you're going to do. You're going to say sum of forces on the y directions equals to 0. And then if ever you check, the forces which are going up is what? 50 is going up, therefore you're going to have your 50 newtons, and also plus AB sine 60 degrees equals to 0. Therefore you only got one unknown there. Your unknown is what? Is AB. Therefore what are you going to do? You're going to say, you're going to take what? You're going to say AB equals to negative 50 divided by sine 60. Therefore, your AB equals to, and then you press it on the calculator, which you're going to say 50 divided by sine 60. Therefore, it's going to be 50 divided by sine 60. Therefore, you get 57.73. Therefore, your answer is going to be negative 57.73 newtons. Therefore, once it says it's negative, since you assume that your AB is on tension, it simply means that your AB is going to be on what? Your AB is going to be on compression. You can just indicate compression and then you leave your answer like that. After you've done with that, you come to the sum of x direction. Therefore, it's going to be the sum of forces in the x direction equals to 0. And then you go back to what? To your free body diagram. You assume C is going to the right. If ever you say C is going to the right, it's going to be positive. Therefore, it's going to be member AC plus AB cos 60. Because AB cos 60, it's going where? It's also going on the same direction. Therefore, it's going to be AB cos 60 equals to 0. Therefore, you calculate for AC because we've got AB. Therefore, it's going to be AC plus, your AB is what? It's negative 57. You don't change that sign because it just indicates that it's on compression. Therefore, according to your assumed direction from the first part, you assume that it's on the thigh. Therefore, now you're going to put that negative, and then you put your cos 60 equals to 0, and then you calculate your AC. Therefore, your AC is 57 cos 60. Therefore, you're going to say 57 cos 60, and then you got your answer as 28.86 newtons. Therefore, after you've got this, you're going to take it on the other side of the equal side, and then you find it as positive. So it means that if ever your AC comes out positive, your assumed sense of the member that is on the thigh, it means that it was right. Therefore, you just put your 28.86 and then you got it on tension. And then it simply shows you that the direction of AC is the magnitude of AC is 28.6 on a tie, and then the direction of AB, the magnitude of AB, it's 57.3, but in a compression. Therefore, this is what I normally do if ever. It simply means that this direction is okay. Meaning this member AC feels 28.86 on a tension direction. But this one is on a compression. So what you normally do, you just change your sign after you're done, and then you put your magnitude on. You put your sense of the feeling on this member on compression, because it simply shows you that there. Therefore, you are done with the first member, and then you move the same way to the second member, which is member B, which is joint. So now we're going to move to joint B, whereby we're going to have a free body diagram on it, which I've already drew here. If ever you check here, we've got member AB, which we got, and now it's on compression because we got the sign of the answer is negative. So even here, on this free body diagram, we're going to break it into its components because we've got our AB at an angle of 60, so we're going to break it to Y component and X component, and also BC, we're also going to break it at its Y component and X component. So if ever you check for AB, because it's going up, so if ever it's going up, we're going to have our component which is going up, which is 57.73 sine 60, which is the component of AB, because that is AB, that 57 is AB. And then also, it's going on this way, which we're gonna have our 57.73 sine 60, cos 60, sorry. So it's gonna be cos 60 here. And then after we're done, we can also have our components of BC. The components of BC is going this way, meaning if ever it's going this way, we're gonna have a component which is going this way, which is gonna be BC cos 60. And also we've got our component which is going down, which is gonna be BC sine 60 degrees. Therefore, if ever we're doing it that way, what we're gonna do is we're gonna check. Sorry about that. So what we're gonna do on this part, we're gonna check on the x components and the y components. So if ever you check, you can see that we've got our y components, which is sum of forces in the y direction equals to 0. Therefore, if ever you check, we've got this one, which is 57, which is that member of B, which they are going up, and we also got the one which is BC, which is going down. Therefore, what we're gonna have, we're gonna say our 57, which is 57.73, which is going up, 57 sine 60 degrees, which is going up. We take it as positive, minus our BC sine 60 degrees, which equals to 0. Therefore, we calculate for BC because there's only one unknown, which is BC. Therefore, our BC is going to be equals to 57.73 sine 60 divided by what? Divided by sine 60. Therefore, it simply means what? It simply means that our BC equals to 57.73. And then, if ever our BC becomes as 57.73 newtons, and it's also positive, it means that the assumed direction of tension is what? Is correct. And then, after we got that, we're going to go to the sum of forces on the x directions. Sum of forces in the x directions equals to 0. And then we go back there, we check the components. If ever we check the forces which are going in the y direction, we've got the BC component which is going to the right. We've also got what? We've got the AB component of which is going to the right. And we also got what? We also got PT going to the right. Meaning they are all positive if ever you're taking forces going to the right that are positive. Therefore, what do you have? You're going to have your BC cos 60 plus 57.73 cos 60 plus BD equals to 0. Therefore, it simply means that all your forces on that direction, they are going to the right. Therefore, you simply calculate for BD. Therefore, your BD, if ever you check your BC, it's also 57.3. So you're going to say 57.73 cos 60 plus 57.73 cos 60 equals to negative BD. Therefore, your BD equals to, then you press it on the calculator, which is 57.73 cos 60, which gives you that, and then plus another 57.73, which is supposed to give you what? It's supposed to give you 57.73 newtons, which is negative. Therefore, if ever it gives you a negative sign, it simply means that you keep that negative sign and then it's under compression. And then you can simply go back to what? Go back to your structure of the free body diagram, since you assume that it's going to go in tension, and then you change the direction and then you put it under compression. Therefore, that is under compression. And then it simply means that you've got your BD, that on that joint it's under compression, and then you've got the value that is 57.73. Therefore, you are done with this part of the free body diagram, and then you can move to another free body diagram. Okay, as we move along, now we're going to this joint, which is joint C. We just got our BC on this side, so now we're coming to joint C. If ever you check joint C, we've already got this member, which is, that member was member AB, which we got from the first part which we did, which was A, and then we got that member as 28.8 newtons. And then we've got this one is 57.73, and then we've got this one which is unknown, and also CE which is unknown. So now what we're gonna do, we're gonna break these ones on what? We're gonna break it onto its components, which is the Y component and the X component. If ever you check that one, it's gonna go like that, which you're gonna have your Y component, which is gonna be 57.73 sine 60 degrees. And then you're gonna have your other component, which is your X component, which is 57.73 cos 60 degrees. Therefore, if ever you double check, that is our joint C. And then you also have this member, which is our member, which is CD. Our CD, we're also gonna break it. If ever you check our CD, which comes from this way, it's gonna go like that, which is our CD. This is CD member. And then you're gonna break it into what? Gonna break it into its components, which is gonna be CD cos 60, and then you're gonna have also your Y component, which is gonna be CD sine 60 degrees. And then if ever you check here, you've got the components of these members, and then you've also got the member which is going that side, which is AB, which was under tension. Therefore you're gonna have that member which is AB. No, it's AC, which equals to that 28.8 newtons. And thereafter, you also got one more member, which is what? Which is CE, which moves from this side to that side, which is also unknown, which is going this side. Therefore, if ever you check all our members which are acting on this joint, they are being broken down now. And then the only thing which you're gonna do what? You're gonna do what we've done before, which you say your sum of forces going up equals to the sum of forces going down. Therefore, you're gonna say your sum of forces on the Y direction equals to 0. And then if ever you check your forces which are going up here, you've only got two forces which are going up. You've got your 57.73 sine 60, which is going up, and then you also got your CD sine 60, which is going up. Those are the only components which are going up. Therefore, what are you going to do? You're going to say your forces going up equals to positive. Therefore, you're going to have your 57.73 sine 60 plus CD sine 60 equals to 0. And thereafter that, you can see that you've got only one unknown, which will give you your CD equals to negative 57.73 sine 60 divided by what? Divided by sine 60. Therefore, you get your CD equals to what? You get your CD equals to negative 57.73 newtons. Therefore, that is your answer. And then you go back, because your CD is negative. Therefore, it simply means that your CD is under what? It's under compression. If ever you check, you will check on this one. We assume that our CD is what? Is under tension. Therefore, you just simply go there and then you change your direction to be under compression, because our previous assumption was it's under tension. Therefore, now you're done with CD, and then you come and check on your components. Forces going, the X components, which is forces going to the left equals to forces going to the right, meaning your sum of forces on the X direction equals to 0. Therefore, we treat our forces going to the right equals to positive, and the ones which are going to the left equals to negative. Therefore, what we're going to do, we've got our component of CD, which is going to the right. Therefore, we're going to have our CD cos 60, which is going this way. And then we've also got plus our CE. This is our CE, which is going also to the same direction. And then we have our AC, which is going to the left-hand direction, which is going to be our AC, which is minus 28.8, which is that our AC. And we also have our 57.3 cos, which is the component of what? Which is that component of CB. Therefore, we're going to have our CB, which is going to come on this side, which is CB minus 57.73 cos 60 degrees. Let me just remove this part, which is going to be minus 57.3, 60 degrees equals to 0. And then if ever you check, you know the value of CD because you've already calculated your CD as what? If ever you check, your CD was 57. Your CD was equals to negative 57.73, which is under compression. So it's going to help you when you substitute there. Therefore, your CD, you've already know it, and then the unknown which you don't have, the only one unknown which we have here is what? Is CE. Therefore, you substitute your CD is going to be negative 57. Negative 57.73 cos 60 plus your CE minus 28.8 minus 57.73 cos 60 equals to 0. Therefore, you punch on the calculator and then you get your CE equals to, let me check for my calculator, whereby I can simple punch it. So it's going to be negative 57.73 cos 60. And then we've got minus 28.8. And then we've got also minus 57.73 cos 60. And then we get our answer as positive 86. Then we've got our answer as positive 86.53 newtons. Therefore, this one is positive, therefore it's under tension, meaning our CE is on the right direction. Therefore, there's nothing which we have to change. So therefore, it simply means that your CE is under tension. Therefore, we've got this one as under tension as 86.53, which is on the right direction. And then if ever you check this one, CD, we got our CD as negative 57, therefore the direction can be changed, which is going to point downwards under the pressure of 57.73. Therefore, it simply gives us the direction, and then we can also move along to point number D. Okay, as we move along now, we're going to joint, which is a D, whereby we'll be dealing with member BD, member CD, and then also member DE. But we also have that external force which we were given. So what we are looking for here, we are looking for the internal force of DE, which is happening on this part of the frame. So now what we're going to do, we've got our CD, which was 57.73, and then we've got our BD, which also was 57, which is on this side, 57.73, and then we've got our 200, and then we've got our DE. So now, it's seemingly that we're gonna divide our forces again according to their components. If ever you check for this one, which is CD, we're gonna put it like that, which is, if it's going up, we're gonna have a force which is going up like that, and then we're gonna have a force which is going that way. Therefore, it's going to be CD, which is 57.73 cos 60 degrees. And then we've got the other one, which is going up, which is also going to be 57.73 sine 60. Therefore, those are for what? These are for CD. And then you also have components. These components are for what? Are for DE. Because this one was for CD. This is CD, which is acting on this joint. And then you've got the ones for what? For DE, which is our DE is acting on the same joint. So if ever you're breaking those components, you're breaking DE on its components because this is DE. Therefore, you're going to have a force which is going down, which is on the y direction, which is going to be DE sine 60 degrees. And you also have what? And then you also have another component which is coming this way because the direction of DE is going this way. Therefore, you're going to have your DE cos 60 degrees. Therefore, you're done with DE and CD. What are you left with? You're also left with what? You're also left with that 57, which is BD, which is going this way. Therefore, you've got your BD, which is 57.73. And also, the other force which is there, it's your 200, which is going down. Your 200 newtons, which is going down. So now, you've got all your forces which are acting on this joint. So you do the same thing. Forces going up equals to the forces which are going down. So now you're going to say sum of forces in the y direction equals to what? Equals to 0. And then you check your forces which are acting on the y direction. Therefore, if ever you check those forces, what do you have there? You have your component which is going up, which is 57.73 sine 60. And then you also have got your DE, which is DE, which is going down, which is going to be DE sine 60. And then you also got your 200, which is going down. Sorry, for your DE is supposed to be negative because it's going down. And then you've got your negative 200, which is also going down. If ever you check, there are no any other forces which they are going down there, therefore equals to 0. And then you make your DE what? The subject of the formula. Therefore it's going to be sine 60. Therefore it's going to be your DE equals to 57.73 sine 60 minus your 200 all divided by your sine 60. Therefore, your DE equals to, then if ever you check, it's going to be 57.73 sine 60 minus 200 divided by sine 60. Therefore, you've got what? You've got your answer as negative 173.2 newtons. Therefore, it shows that the direction of DE, which we assumed it was going to be tension, it's not tension, therefore it's what? It's compression. Therefore, you go back to your free body diagram and then you change the direction for DE to be what? To be compression. And then if ever you check now, you've got all the members which you wanted, which is your AB, your AC, your BC, your CD, your CE, and also your DE. You find our AB as 57.3, which is under compression. We found our AC, which is 28.8 newtons under tension. We find BC as 57.73 under tension. We found our BD as 57.73 under compression, and then we found what? We found our CD equals to 57.73 87.7 under compression. Our CE is 86.5 under tension. And then our DE, it's 173.2 under compression. So it simply means that all the members which are under the structure which were given from the first part, we found all our members, which is member AB, member BC, member AC, CD, BD, and CE. Therefore, the only part which we're going to be doing now, we're just going to prove by checking this joint, which is joint C. Okay, now we're done with joint at D. So now it's joint at E, but joint at E, there's nothing much that you are doing because we've already got all the members. If ever, what's the magnitude of it, and then it's under which stress, is it under tension or is it under compression? But now, we're just gonna move down a little bit down to joint E. And then if ever we check at joint E, as we've got our DE, which was under compression, what we're just gonna check here, if we're just gonna check on this joint, since we did not touch it at all, we're just going to check if ever we make the sum up of forces, are they giving us what, are they in equilibrium or not? Because if ever they supposed to give us the sum of the x forces equals to 0 and the sum of the y forces equals to 0. So if ever we check here on this joint, joint E, you've got our force, which is 86.5, which is member CE, which is under tension, as we found it, which is 86.5. And then we've got our 150 newtons. Our 150 newtons is the one which we got on the first part of the session, which was on the reactions. And then now, we've got our DE. Our DE is the one which we just found now, which is 173.3, which we're going to break it into its components, which is it's gonna go down. The components is going down and also going to this side. And then our x component is gonna be 173.3 cos 60. And then this one is gonna be 173.3 sin 60. Therefore now, if ever you check on our components, you're going to have the sum of forces on the y direction equals to 0. Therefore, we've got two forces which they are going up and down. Therefore, you're going to have our 173, which is going down. Our 173 is going down, which is 173.3 sin 60. And then we've got 150, which is going up, plus 150, which equals to 0. And then if ever you punch that in the calculator, it's going to give you what? It's going to give you 0 equals to 0. Which simple means that it proves that all the members which we calculated, they are coming into equilibrium. Even if you try it with your sum of x forces, sum of forces on the x direction, it's going to be 173, which is positive, 173.3 cos 60, and then you've got your 86, which will be negative, 86.5, which is negative, which equals to 0. And then if ever you add the 2, you're going to have your 86.65 minus 86.65, which equals to 0. Therefore your 0 equals to 0. Therefore it shows that all your joints, they're in equilibrium. And then when you are done with that, you will have your answers, which will be like this: AB, AC, BC, and BD, CD, CE, and DE. And then if ever you check, you take all those answers and then you come and plug it on your final structure of the frame which you were doing. And then if ever you see, you've got your AB under compression on this joint, then you've got 28, which is this member AC, which is 28.8 newtons under tension. And then this one, it's going to be 57.7 under tension, and then that one is 57.7 under Compression, CD 57.7 under compression, and then DE it's 173.3 under compression, and then your CE it's 86.6 under tension. All this frame feels those internal forces when there is that 200 newtons which is plugged on top of that point on point D. And then that is the end of the session for this type of frame. It's all what you have to keep in mind. The simplest way which I saw it is just by breaking your structure, your full structure of a frame into its free body diagrams. And then if ever you've got your free body diagrams, it's going to be easy for you to see the internal forces which are being applied on each member. And another thing which you don't have to forget is that if ever you found your answer negative, it shows that your assumption of the field, if ever you assume that all the members are in tension, because I like to assume all the members that they're in tension, so that if ever you find your answer as negative, quickly go back to your free body diagram and then you change that member to go back to what? To compression, and then you continue with the direction which you find in the answer. That's all for today's lesson. Thank you very much.